Here's a little addendum to problem 23.9. Let's say you worked out this problem and you looked at these two directions and you found F1 going off like this at an angle theta, and then you found F2 going off like this also at an angle theta, and F1 was equal to 0.691 newtons and F2 was equal to 0.922 newtons. And if you know theta, it's a 3-4-5 triangle. So you got your situation like this, the 4, the 3, and the 5. And here's your angle theta. And you could do the inverse tangent 3 over 4, but you would determine that theta is 36.9 degrees, and the other one being 53.1 degrees for alpha. So the angle between these two vectors is 36.9 plus 36.9, so this total angle here is going to be 73.8 degrees. Now if we were to add these two vectors together, say if we had an F1 added to an F2, let's do this again. Here's F2, and then we add F1 to that in such a way that this angle right here is 73.8 degrees, and that means that the angle between these two vectors is 180 minus that, so that's going to be 106.2 degrees. Alright, between F1 and F2. My point is that we can find the resultant vector of these two added together, which is this vector here, by using the law of cosines. The law of cosines says that a squared plus b squared minus 2ab cosine gamma is equal to c squared. In this case, this is the c we're looking for. Here's a and here's b. Alright, and we know the magnitude of a and b, so we can do this. So in other words, c is going to equal a squared, which is 0.922 squared, plus b squared, which is 0.691 squared, minus 2 times 0.922 times 0.691 cosine 106.2 degrees. And all that square root. So if you calculate that, what do you get? 1.297. So that's the magnitude of the resultant vector c, which would be the magnitude of our resultant vector, 1.297 or 1.30 if we round it up. And that's the same answer we got by finding the components of all the vectors and adding them together. Not necessarily a shorter method, just a different method for finding the magnitude of the third vector.